Hi guys, welcome back. Today we're doing reduce array size to the half. So we're given an array of integers called r, and we can choose a set of integers and remove all of the occurrences of these integers in the array. So they want us to return the minimum size of the set so that at least half of the integers of the array are removed. So in example 1, we're given this input array, and we would output 2 because choosing 3, 7 will make the new array this, which has a size of 5, which is exactly equal to half of the size of the old array. So the old array, as we can see, has 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 elements. And so, as they set up here, we want at least half of the integers in the array removed, while returning the minimum size of the set. So half of an array of size 10 would be 5, and so we want to remove as little unique elements as we can, basically, because that's the minimum size of the set, to have half of the elements left in the original array, if that makes sense. So because we can remove 3 5s and 2 2s, we can remove 4 3s and 1 7, which will cause the array to have a size of 5. Okay, and that's 2 unique elements, so then we would output 2. In example 2, we're given this input array, and we would output 1 because the only possible set we can choose is 7, which will make the new array empty. So then we just return 1 because there's only one unique element that we can actually remove. So in this one, the best strategy is going to remove the elements that, like the unique elements that we have the highest frequency of, because that way we can remove the least possible unique elements while removing the most numbers, if that makes sense. So like if we remove 3 in example 1, then we can remove 4 elements from this array, versus if we remove, like, let's say 2, we can only remove 2 elements. So it's more favorable to remove unique elements that elements that have the highest frequency. So to track the frequency, we can use a hash map, and then we can basically sort the frequencies in the hash map to remove elements in order of highest to lowest frequency until we get to a size that is at least with half of the integers removed. I hope that makes sense. We'll see as we do this problem together. So I'm going to copy and paste the example 1, and let's put indices as well. So 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, now we're going to make our hash map. So we'll say integer in integer. And then this is going to store the number and the frequency. And it starts out as empty. Okay, now we're just going to go through the array and populate the map with all of the numbers and their frequencies. So for int num in array. So we're going to loop through this entire array. Then we'll just say map.put the number. And so like if we already have it, then we're just going to increment it. If not, then we'll add it with a count of 1. So map.get num, put get or default num 0 plus 1. Yeah, there we go. So now we're going to populate the map. So as we go through, in the first iteration, num is 3. We do not have a 3, so we'll put 3 with a count of 1. Then the next one will be with a count of 2, because we already had it, then 3, then 4. And you guys know how this goes, so I'll just fill out the rest of it with what we know is going to happen. And yeah, so this is what our map will look like once it is populated. Okay, now we want to create a list of just the frequencies in the map, because we don't actually care about what numbers we are removing, right? We just care about two things here. We care about the number of, like, the frequency of whatever number we're removing. So like if we remove 3 from this one, for example, we care that we are removing 4 total numbers from here. We don't actually care that we're removing a 3, right? Because they only ask for us to return the size of the set, so the number of unique numbers that we are able to remove. And we also need to keep track of the total number of integers removed. So like if we remove a 3, we remove 4 numbers. We need to keep track of that so that we can know when we have removed at least half of the numbers from the original array, right? But other than that, we really don't care about what the number itself is. That was like a really long rant, but anyway, so let's keep going. So we are going to create a list to store the frequencies of this so we can just easily loop through that. So list of integers, and we'll call it counts. And we'll just fill it up with the values of the map, so map.values. Okay. And so then this will store, well, okay, first it'll populate with these numbers, so 4, 3, 2, 1. Although we actually also want to sort this in decreasing order. I know this one just happens to already be sorted, but in case it's not. And also there's no guarantee that it is sorted because maps don't have an order, right? So we're going to sort that, so collections.sort counts, and we're going to do reverse order so that it's in decreasing order, so just like this. So now that it's in decreasing order, now we have the maximum in the front. So as we go through, we're going to automatically be removing the most possible numbers at a time that we can, because this is representing like we don't even care that it's representing the 3, but we know it's representing the 3, right? So like when we'll just remove 4 at a time, then 3 at a time, and so on until we get to half of the total size. And yeah, that's how we're going to do that. So we'll keep track of how many we have removed so far, which we start out with 0. And we also want to keep track of the size, which will start at 0 as well. Which is going to be the size of the set, and then this is going to be the total numbers that we have removed from count. So like if we start with this, then we have removed 4, right? But we haven't actually done that yet. So right now it's 0. Now we're going to loop through counts and go ahead and do that. So for count in counts, we will add whatever number we're currently at to removed. So we'll remove that. And we'll increment size, because the size of our set, or whatever this thing is, right? The size of our set is going to increase by 1 every time we get to one of these, because this is representing a new number every time. So size plus plus. Okay, and then if we have reached at least half of the integers of the array being removed, then we just want to exit because we're done. So we're going to do a check. So if removed is greater than or equal to the length of the original array, length divided by 2, then we can just break because we don't need to do this anymore. And then we're going to do this for every single element in the array. Or in the list, sorry. So we'll start from 4, let's just walk through this example. So we start at 4, count is 4, removed will plus equal count, so removed will be 4, then size will increment, so size is 1, okay, and then have we reached length divided by 2? Well, our original array had a size of 10, right? So 10 divided by 2 is 5, so we just need to get to 5 at least before we can break out of this for loop. So have we gotten to 5 yet? No, because removed is 4, right? So we have to keep going right now. So then the next iteration, we're going to get to this 3. And so count is going to be 3. Then removed will plus equal count, which will be 7. Then size is going to increment, so size is 2. And then now is removed greater than or equal to length divided by 2, which is 5. Yes, because 7 is greater than or equal to 5. So now we can break out of this loop, and then we just want to return size at the end, because size was the number of unique numbers that we were able to remove from the array. And it doesn't, like, technically we did this in a different order than they did here, but it really doesn't matter because we get the same result in the end. So let's check this. All right, so if we think about the time complexity, okay, so we'll start from the very beginning. So here in this loop, this is going to run O of n times because, or n times, but it has a time complexity of O of n here because we are just looping through every single element in the array exactly one time. Like we're visiting every single one once, and then we're just putting it into the map, which is going to be O of n for this part. Okay, and then in the next part, we create this list and we store all of the map's values in here, which is going to be proportional to the number of unique elements in the array. But worst case, that's going to be the same as n, so we can just say it's n. And then we sort it, which sorting is going to be O of n log n. So this is O of n log n, which again, it depends on the unique elements, but worst case, it's still going to be the same as the number of total elements. Because if we have a case where every single number is unique, then we're still going to have to process every single number. So then after that, we have this loop where we are just looping through the counts, and that is also going to be O of n. Because, again, so this will be, so if we have all unique numbers here, then count will just store 1, but like it'll store 1 n times. So we're still going to loop through n times total. So then if we add all of these up, because everything else is constant, so we don't really care about that. So O of n plus O of n log n plus O of n gives us O of n log n total. So our time complexity is going to be O of n log n, where n is the number of elements in our array. Okay, then our space complexity. So we'll take a look at all of our data structures we have here. So we have our hash map, which will store worst case O of n. Again, because if every single element is unique, then we are storing every single frequency, or every single number, which is n, with a frequency of 1. So this is O of n, space. And then our list it's like literally the same thing, because it's just storing all the values of the map, right, which is going to be O of n worst case. And that is all of our data structures. So our space complexity, if we add those up, it's O of n plus O of n, which gives us O of n, where n is the same thing. So that is it for this problem. I hope you guys found this helpful. If you did, please like and subscribe, and I'll see you next time. Bye!